So before we continue to analyze and create our machine learning model on Databricks, I want to do some filtering on the dataset over here to basically make it smaller. Now, although you can perform the analysis on the whole transaction file, but it is a bit challenging for me since I'm using the community version of Databricks. I can't analyze such large files with a limited number of time. While I was working on this dataset, I used Databricks, and at that time it took me around 40 minutes to run the code. I don't want this video to take years to make, and since I'm also going to do some crazy stuff by the end of this video, we are going to do experiment tracking through MLflow. So it is not feasible for me to use the complete transaction files having a total value summing up to almost 90 lakhs for the analysis in the end. And it is very challenging for me to handle this and make video at the same time. So although you can do it on your side, you can try it on your side. You can check it for any other card brand as well. For this video, we are going to make a machine learning model to detect fraud only for the MX card brand. You can do it for Visa, MasterCard and Discover card as well. You just have to change a single line of code. With that said, let's first convert the JSON files that we had having key value pairs to a CSV file. Okay, so over here in my VS Code, we have created a JSON to CSV notebook. We have created a separate folder as data processing for it. If you want to access this notebook, if you want to access the code, we have earlier performed the statistical analysis as well. If you want to access that code, you can go to my GitHub repo, which I will be sharing in the description. You can use that code as well. Regardless of that, let's continue the discussion of converting a file of type JSON into CSV. For that, we need some dependencies or some libraries which we are going to import. You can say that import JSON and it will import the library. Do the same thing for all other. Now define the path of your JSON file. Over here, we have the JSON file in the data. We are putting these two dots because first we want to come out of this folder and then we want to go to the data folder. If we will not put these two dots, it will find the data folder in this particular folder itself, which is data processing, and it will not get it. So it will throw an error. So make sure to first get out of the current directory or the current folder that you have. Sorry for this. And then you can go to the new folder that you want to go. Okay. So yeah, it's a basic thing which you should know. Similarly, we'll also give the CSV path, which we will make like a CSV file. So that CSV file will be stored as mcccodes.csv in the data folder only. And after that, if we don't have the data folder, we will make sure to create one if we don't have the data folder. So it will only create it if we don't have the one. Okay. So if it is existing already, it will not create a new one, or it will not delete the current one and create a new one. In the data folder, we have other files like cards.data.csv. We have the train fraud label.csv, which is not actually given by the Kaggle dataset. It was in the JSON file format, but we converted these two files, which is mcccodes.json and train fraud labels.json to a CSV format over here. And for that, what we are doing is we are opening the JSON file and then we are loading the JSON data and we are basically converting this to a dictionary. And in the end, we are opening this and again, we are converting the dictionary that we created into the CSV format. Okay, so again, this CSV path refers to the path that we assigned over here. This is an empty file which was created at the beginning of this code. And then we filled this into a write mode and we gave this field names as MCC code and description. And what we basically did was we took these two values of MCC code and description from the JSON file and we converted those two values into CSV format. So this file is really small, only having 109 values. So I can show you, but I can't show you this train file, which is my train fraud labels. So when you go to this MCC code right now, it's in the format of JSON. So you can see over here, we have this curly braces. We have the unique ID, which is MCC code and corresponding business to it. There are total 109 unique values over here. So we have all of this. We converted it into a CSV file and it looks something like this. On the top, we have the headers as MCC code and description. Okay. Similar to all other files we had, like cards data. Over here, we have these many values and these are all the fields that we have. Okay, so I hope you understand what we are trying to achieve over here. After this, it will show that we have created the CSV file. I will not go step by step again because you can easily understand this. We have the right headers to get the headers, and then we are going to write the rows in which we will pass the dictionary which we created over here. Okay, having the MCC code as key and description as value. We are going to fetch all the key values from the JSON data.items which we fetch from the JSON files over here. You can look at this code, you can understand it. If you are unable to understand a single line of code, you can either comment in the video for where you are basically stuck in, or the better solution would be to use any kind of chat model to ask him what solutions you can make to solve the error, or if you want to understand what's going in the code, you can do that as well. Okay, so we created the CSV file. We also checked the CSV file. We can also, now it's a CSV file, so we can read this CSV file using pandas. So pandas pd.read CSV, and we are passing the path of this file, and then we are just saying that df. So what df will do, it will show all the values. So in total, it starts from 0 and into the number goes to 108. So we have total values from 0 to 108. Although the unique keys are not from 0 to 108, we have MCC code like 5812, we have MCC code like 5941, and like that we have total 109 unique MCC codes in this CSV file. Similarly, we will do it for the train fraud labels.json file will come below. We will assign the path to the JSON file and also to the converted CSV file which we will make. After that, if data doesn't exist, we'll create this repository, folder. Then we will open this file and we will fetch this JSON file into this JSON.data. We will assign the target data as JSON target. So what is the problem with my train fraud labels is that in the MCC code JSON file, initially we have the key and values. But in this train frauds label, we are not having directly the transaction ID and whether that transaction is fraud or not. Initially, we are having the main key as target, and in the target we have all these transaction ID and whether the transaction is fraud or not. So you can check back to the Kaggle link which I have provided. Over there you will understand what's the difference between MCC JSON file as well as this fraud labels JSON file. So what I'll do is I'll quickly just fetch this target over here from the JSON file, and in that target I have all the key value pairs which is like my transaction ID and whether that transaction is fraud or not. And I will convert it into a list just like I did before, and then I will assign this as the row headers, and I will pass the rows from the list that I have just recently created. After I do this, it will take some time to run because it's again a big file having almost 90 lakh rows, and the total size is 158 MB, so it will take some time to run. You can use polars over here on your side to make this a bit faster. Okay, although I didn't use it because it was working well for me, but still polars is a good option. It will cut off the time by almost 5%. Polars is really fast. And then if you want to check whether this CSV file is working perfectly, you will create a data frame using pandas for the CSV file, and after using df we get this whole file as transaction ID and fraud label. So in total we have 89 lakhs rows and only 2 columns. I hope you understand this. After this, we have polars as PL, and what we are doing is we are basically importing polars because now we are going to read the POS file, the daddy file, which is my transactions data. It's of 1.2 gigabytes, so I had to use polars this time. I didn't had any option. So after that, I'm going to count the unique ID that I have in this data set, and which says that in total we have 1 crore 33 lakh transactions, a unique transaction, which is like 13 million transactions, a very big number, a very fat number. So yeah, 13 million transactions to work with. I can't do it because Databricks doesn't offer me this much compute. So in the community version, we get some compute to work with. And so what we are going to do is, first let me explain you what we are going to do, then we will do the code, because coding is easy. Nowadays, coding doesn't matter. The concept does matter. Okay, so let's understand what we are going to do. I have this transactions fraud label, which will be having a transaction ID and whether that transaction is fraud or not. In total, I only have 90 lakh values, or I would say 8.9 million values. But in my transactions data, I have 13 million transactions, which is equivalent to 1 crore 33 lakh transactions. But I only have the fraud label for 90 lakh values or 8.9 million. What about the remaining 30 or 40 lakh transactions? For that, I don't know whether they are a fraud transaction or not. So if I don't know whether they are a fraud transaction or not, how can I apply machine learning model onto that? Because when you apply any machine learning model, over here we are going to perform classification model because we want the output as yes or no, whether a transaction is fraud or not. So what we need to at least know for the model which we are creating whether that particular transaction is a fraud transaction or not. Then and then only we can apply a machine learning model to the test to basically get its performance, analyze the ROC curve, AUC, everything like that. So for that, we need to know the fraud label. Since we only have the fraud label for 89 lakh values, I will filter this transactions data to only those values for which I know that the fraud label exists. And I will filter out this transaction dataset with only these values. And I will remove all the transactions whose ID is not present in my fraud labels dataset. Understand this thing? Because see guys, if you will not understand what is going on, you will create this project and ultimately you will be like still a one who doesn't know anything about the project. So yeah, my great English, I know. So yeah, so basically what you need to do is you need to filter out the transactions data that we have with a filter that whether that transaction ID is present in this other CSV file or not. If it presents, that means for that particular transaction, I know that filter, that fraud label exists or not. So fraud label exists, okay? So only in that condition, I'm going to keep that transaction. Otherwise, I will remove that transaction ID, that whole transaction basically, because that will not be useful for my machine learning model, okay? That will not be useful for my machine learning model. And yeah, so that will be my first step. Again, after doing this, I will be still remaining with 89 lakh values. Although it is 25% lesser than or 20% lesser than my initial value, which is a big fat number, 13 million transaction, but still 89 lakh values is still not a small number. So again, I will apply one more filter in the transactions dataset. As we know, we have the card ID. So I will filter out all the cards where the card brand is MX. And now the transactions which initially were around 13 million, which we took to 8.9 million after applying the filter of only choosing those transactions which are available in my fraud labels.csv file, to now with the third filter, to the second filter, which is adding the card brand as a filter. So only those transactions where the card brand was MX. So after that, we get only 5.7 lakh values to work with, which is a reasonable number for the analysis, especially when we are working on cloud platform. So yeah, that's it. So for that, we are going to go to this file over here. We are going to use spoolers over here. We are going to first read the transactions dataset. We are going to read the fraud labels.csv file, which we just created. Although I have not run the code because it will basically just crash this video recording. My computer is not healthy enough to do all this task at the same time. So after that, we are going to apply the join between this fraud labels.csv file data frame, which I have over here as df transaction for the transactions data, and for the fraud transactions CSV file, I have it as df filter transaction. Oh no, I have it as df fraud labels. So I will filter the transaction. So I will create a new data frame as df filter transaction, in which I'm going to select the df transactions, and I'm going to join this with df fraud with a left join on ID and the right join on transaction ID. So transaction ID is a unique ID of every transaction which is available in my fraud CSV file. Okay. So after applying this join, inner join, basically what will happen is all the transactions which are present in my fraud labels will be only shown in this new data frame, which is my df filtered, along with all other details which we had in the transactions data file, which is like the date of the transaction, the amount of the transactions, which are not something that we had in our fraud labels. Because in fraud labels CSV file, we only have the fraud label and the transaction ID corresponding to like a transaction ID, and corresponding to that we have a label as fraud label, which can be yes or no. Okay, so after doing this step, we have filtered the value. So now from 13 million, basically I will write over here, from 13 million we cut it down to 8.9 million. Okay, which is again a big fat number. So what we will do is we will import this card data over here and convert it into a data frame using polars this time, because it's much faster than pandas. And since I'm using for this analysis also, like for this conversion also, I'm working with fraud label file, which is 153 MB, and the transaction files, which is again 1.2 gigabytes. I had to use something faster, so that's why we are using polars. So after creating a data frame for the cards CSV file, we are combining now. We are basically, now this is my main file, df filter transaction. So I'm applying the join with this transaction where my card ID is given and the ID is given on the right. So after applying the left join, what I will have is all the transactions, even if the card data is missing. Oh, wait. All the transactions, even if the card data is missing. Left join, all the transactions, card ID. Yeah, okay. So basically, or for all of my transactions, it will filter out it on the basis of like the card ID and the ID that we have over here. So let me explain you this. Basically, this comment is not perfect. I'll remove it. Yeah. So what we are doing is we are basically, yeah, okay. I got it now. Yeah. So what this code is doing is we are basically combining our filtered transaction, which is 8.9 million values, and the cards over here. So DF cards. So I'm merging these two tables. And on what condition I'm merging? In my DF filter transaction, if you saw the transactions data initially, we discussed about the files previously. Over there, we had card ID. So on basis of that card ID, and in my DF cards, we have unique ID as ID, which is my card ID again. So on basis of these two rows, so this is basically my primary key. ID is my primary key for DF cards, which will work as a foreign key, having a reference to my DF cards. So this is my foreign key, card ID, which is in this DF filter transaction. So card ID is my foreign key for DF filter transaction, which refers to the card details which I have in DF cards. Okay. So after applying this join, what it is saying is that it will filter out it will basically join these two files, and it will also keep all the transactions where the card ID is not defined. Although it's not needed, but still it has made sure that if there is some card ID which is not present in my cards dataset, then also it will keep it, and it will put all the values as null, like for the card ID. Like if I will merge these two tables, what will happen is, if in the card ID we have all these details, so now along with the transactions data that we initially had, this all rows will also be, I would say, attached with my dataset, which is my transaction dataset. And if for some card ID, if that card ID is not present in my cards data, for that card ID, it will put all these values as null. Okay. So it's a very basic thing. Again, nothing really advanced. And after that, what we are doing is basically we are filtering all the all the values in our 89 lakhs of rows, like our 8.9 million, just a second, 8.9 million rows that we have in the DF combined data frame. We are filtering all these values with a condition where card brand is MX. So since I have combined this transaction file and the card file, now I also have card brand in my columns, and I will check whether that card brand is MX or not. So for a particular transaction, if a card brand is not MX, I am not going to consider it, and I'm going to filter this whole with the condition that card brand is MX, and I will store it in this new data frame as DF MX transactions. PL.column basically selects this particular column, and then we are checking whether that column is MX or not. It's a very basic thing. If you want to analyze for MasterCard, so you just have to convert this MX into MasterCard. You can just write MASTERCARD. Similarly, for Visa, you can do it, and so as on for the other two cards that we have. Okay, so which is my discover. Okay, yeah, not other two, only other one. So yeah, error is gone, and you can see we have filtered all the transactions with the card brand was MX. After that, we can perform this, although it's not needed. So I will remove it because it is basically filtering to all the values that you need. So I don't want like this. I want all the values. I don't want to filter it. So yeah. Oh, just a second, guys. Yeah, I do want to filter it because I don't want the details about my card now. So since this combined transaction will have details of my cards as well, but I don't want it. I just want the format of columns as I initially had in my transactions dataset. So what I will do it, I will fetch only the transaction ID, the transaction date, the client ID, the card ID, the amount, the merchant ID, the card brand, also the MCC code as well. So I will write it over here. I forgot the column name, so I will do that as well. I think it was MCC code only. Still, we will check it. And the last one was probably, I don't remember. It was, yeah, we had the fraud label as well. I guess, yeah, that's it. Yeah. So this is the last columns that we have, and we are going to work with this data set. So let me just quickly run this again because we have added MCC code. Previously, we forgot about it. Okay, we can't use this right now because we have not added MCC code to this data. Okay, I got it. Because see guys, MCC code can be only added when we have it. Right now, we don't have MCC code added to this data frame. So we can't add it. So in future or maybe in the Databricks itself, we will add MCC code. Right now, it's not needed. It's fine. So yeah, I just had to press Control Enter. Let's run this file. See, after running this, it will probably freeze my screen. But don't focus on my video, just focus on this. It is taking still a lot of time. It will take around 40 to 30 seconds or something like that. But if you will perform the same using pandas, it will take around 2 minutes or maybe more than that. So that's why polars is fast. And I would recommend you to try with pandas as well, so you understand the power of using polars from the next time in your data analysis project. Okay, so just wait for some time. Maybe in the couple of minutes, we'll be having our file ready. Yeah, it's loading, it's loading. Let's wait. I don't know why it's taking more than 50 seconds. Earlier, it definitely didn't took this much time. Let's just hope it works because it's been a very long time since I'm recording. Yeah, it crossed the 1 minute mark. Definitely, pandas will take more than this because again, its polars is fast. I think because of recording at the same time, maybe. So yeah, as you can see, we have successfully stored the file as mx filtered transactions.csv. Now let's go to Databricks and set up our cloud over there and do the further analysis over there and start by making our machine learning model.